What we're trying to get here really with the historical angle is not necessarily something that they would do directly, but I think indirectly it feeds itself really well into the rest of the topics. Atomic structure, topic 2, periodicity 3, bonding 4, all of these ideas just run throughout the whole course. So to kick off today, what we'll be doing is looking at atomic structure. And we'll be taking you through this almost like a guided tour. So we're at the very start now. Within the next 50 minutes or so, within the end of the lesson, we'll hopefully be at the end and you'll have discovered the same kind of ideas that the scientists before you had discovered. This gentleman, Democritus, so what kind of ideas do you think they were throwing about at the time of 400 BC? Perhaps what misconceptions they might have carried. So at the beginning with the ancient Greeks, we actually tried to get them to look into the divisibility of matter. And then when we get them all around the desk, we can really dive into what had the Greeks proposed at that point. What did they know? But more importantly, with that first activity, what didn't they know? So Lucy, how do you think this might relate then to Democritus' ideas?
Would it be like he's come up with the first kind of concept that links to all the atoms and like how they work and react around us? Theory of knowledge and links to the way we're looking at history, because we'd look at it and be like, oh, so thousands of years ago they believed this was right, and then they managed to challenge this more recently. So obviously it gets rid of like a whole concept and kind of like builds on it. What we're going to be doing is fast forwarding from 400 BC, quite a large jump here, into the late 1800s, in particular 1897, and looking at a gentleman named J.J. Thomson. Any ideas on what this wonderful, groundbreaking discovery could be that J.J. Thomson?
So the discovery of subatomic particles might add to this, for example, electrons, neutrons, protons.
The cathode ray, the beam of electrons that's being accelerated, is being attracted to this terminal down here. It is therefore the anode. This gives us an indication of the charge of the particle. What might the charge of the particle be?
Negative.
Negative, good.
Theory of knowledge alongside with science works really well because it helps you to not accept things at face value, because we're used to accepting, we hear Albert Einstein and think, oh, he must be correct. But then theory of knowledge, bringing into reasoning, the scientific methods, we learn to think about how we could formulate it in a different way and how he may not be right and how he may be right.
Hantaro Nagioka. He obviously contradicted this idea of the plum pudding model and said this wasn't quite correct with these Saturnic rings. He came up with two very good points with regards to the positive mass and with regards to electrons orbiting and going around. For what reasons might Hantaro Nagioka not have been covered in textbooks as much as other Western scientists?
If you look at Nagoto, he came from Japan, as opposed to J.J. Thomson, who comes from Cambridge, so obviously he's going to be a more renowned scientist and more respected as well.
Japan had a very isolationist policy, so they wouldn't have been in direct communication with like the Americas or the Western world.
Brilliant. Yeah, fantastic. In 1911, Rutherford conducted an experiment using a piece of gold foil, and he fired alpha particles at this gold foil. This is your alpha particle. What you're going to do is fire these alpha particles at our atoms. What you then need to do is to look at the angle of deflection. The Rutherford experiment was a brilliant one. It's really hands-on, gets them involved. It's using quite crude substitutes, if you like, for the particles with the marbles, having our plastic cones instead of gold foil, but nevertheless, it gives them an idea.
So these active parts of the lessons really help to take off the page and off the board what we're learning in theory lessons and just help to bring it to life and let us sort of imagine what's actually happening.